Hi, Ari Styles, and this is Amanda Ondale, your conference goddess. I traditionally design the books for Smashing Magazine, but I'm always so thrilled to come and work at the conferences and actually get to see all of your faces and meet some of the people who read the books and some of the people who write the books. So this is always really fun for me. And raise your hand if this is your first jam session. Okay, I'm right there with you. This is mine too, so I'm actually really excited to try something new here. But also, let's back up a little bit and say, how many of you, this is your first Smashing conference? All right, we are so glad to have you. It's going to be a great night. So without further ado, let's get started with our first speaker, Max Ferreira.
Thank you. Hi. Hi, thank you. Thank you for having me. My name is Maxi. You can find me online as Charga, different places, Twitter, LinkedIn, Blue Sky, anyone's there. And I work at a company called HubSpot, the front developer. And today I want to talk to you about a recent project we worked on, which we saw how reducing a bundle size of a piece of JavaScript, like just a few kilobytes, can end up saving hundreds or even thousands of trees. So let me start. I want to start by giving you just a bit of context about this project and this product in particular. So one of the products that we have at HubSpot is called Beacon. It's a chat widget, basically. It's a third-party script that you can create via HubSpot. You can install it on your website. You can customize it, and you have chat working on it. It's a pretty fully featured product. Has a ton of features. Customers are pretty happy with this product. But it had one major issue, which is that the performance was not very good. For this little chat widget, we were shipping about 260 kilobytes of JavaScript, which you can see, maybe you can see in the screenshot, is that little button, the green button there, which on a blank page of just HTML, it was dropping the Lighthouse performance score to 79. Now, all of the numbers that I'm going to share here in terms of bundle size, these are all GC. These are all compressed JavaScript. So if you are compressed, it's even worse. And the Lighthouse scores are all from page speed on mobile, just to get out of the consistent metric. So we weren't happy with this, of course. We wanted to do better for our customers and their customers. And so we set some goals. We wanted to get the bundle size under 100 kilobytes. That was our initial goal. We also wanted to get as close as possible to a 100 Lighthouse score and to reduce the blocking time on the main thread to 0, essentially, or almost 0. So we started by taking a look at the bundles. This is a screenshot of our Webpack analyzer. There's a lot of stuff going on. We're doing some code splitting, but the bundles are still very busy. So we started to say, okay, what's our baseline? What's the minimum amount of things that we need to run on the page before we can start rendering something? So this is our stack for Beacon. We have React and React DOM. By itself, that is already 38 kilobytes. We have Redux, it's a Redux application. We have style components because fortunately our design system uses style components, so we have to have a library. We have React Ladder, we have a bunch of other dependencies. So our baseline is already 82 kilobytes. We knew that our goal of getting under 100 kilobytes was going to be hard because this doesn't include any actual application code yet. So you might be thinking right now that this doesn't look like a very good stack. Like this looks over-engineered. This looks like a bunch of dependencies for just a little chat widget. And yes, you're right, that it's a lot. But I will say two things in our defense. So Beacon has been around for 8 years now. The first version is from 2015. We rebuilt it in 2017, which is when we defined this stack. And at the time, when you build an application, a web application, that was the standard stack: React, Redux, React Ladder, and also kind of performance wasn't as front and center as it is today. A lot of the tools that we have today didn't exist back then. Core Web Vitals didn't exist. Lighthouse was only starting to sort of add performance metrics. So I'm not saying that our choices were right. There was definitely something that we could have done better, but this was kind of the standard. Also, while it looks on the surface like a simple product, which is some chat functionality, Beacon has a lot of features. It has knowledge-based search, history of previous conversations. It has in-app messaging. It has theming, internationalization, an API. It has a bunch of things. It's a fairly complex application. It's essentially a mini app running within your website in an iPad. So we figured that the right thing to do would be to rebuild this with a better step. Maybe use something like Solid.js or Svelte, something that optimizes for a small bundle. But we figured out with all of this complexity, all of these features, re-implementing that would take at least 6 months for our team of 2 people. We're only 2 developers working on this project. We didn't have 6 months. So what can we do in 2 weeks? We went with the very scientific approach of just trying a bunch of stuff. And we had some ideas already. So in the first week, we tried a lot of things that we were just playing around in our heads for some time. We replaced React with React, which was pretty straightforward. It was very easy to do, thankfully. We removed IE support because it was a lot of time. We also replaced some nested dependencies that we had. We went more aggressively in our code splitting strategy. So by the end of this first week, we were doing a lot better. Bundle size was almost half than what it was before, and Lighthouse score was in the 90s. That was pretty good. But still, you see the blocking time there. It's 300 milliseconds in the orange. That was bothering us. So we went a bit further and said, what can we do to further optimize this? We came up with something that's called a facade, or essentially a fake version of Beacon. Or at least the thing that is rendered on the page as soon as the page is loaded. So facade is this fake beacon that when you interact with it, it loads the real thing, and then it seamlessly kind of switches one for the other. This works really well, and not working really well. You, as a user, you don't notice how this happens, even if your connection is slow. So we were pretty happy with this, and we're even happy with the results because now we were able to drop the bundle size to 33 kilobytes. Is almost 90% less than what we started. And the Lighthouse score now we finally reached the 100, and the blocking time, we're not blocking the main thread at all. You see that 0 now. So these are really good numbers, but I promised to talk to you about the impact that it has on the environment. And the reason that we can have such a large impact is that Beacon is a very popular piece of Java. Looking at our CDN logs, you can see we get 1 billion requests per month for this script. A lot of those requests are cached, so the actual number that gets downloaded to browsers is around 400 million, which is still a lot. So we have a lot of leverage here. We already saw the impact on user experience and performance metrics. LCP and CLS were not affected before, they continue not to be affected now. But now, first input delay, the other core web vital, at least for now, was now a lot better. We thought it was a lot better because the blocking time was now between 0 and 10 milliseconds. It had an impact on cost as well, because reducing that bundle size by a few kilobytes, with these 400 million requests, it means that we're saving 60 terabytes of transfer per month, which reduced our CDN costs by about 22K per year. And then finally, in the environment, those same 60 terabytes, transferring those terabytes contribute about 43,000 kilograms of CO2, which is roughly the equivalent of what 1,740 trees absorb in a year. So how do you get these numbers? You essentially need to know 3 things, the 3 numbers at the top. You need to know your transfer size. In this case, we knew from the CDN logs that it was about 61 terabytes. You need to know the energy consumption, which is how much energy is required to store, transfer, and execute 1 gigabyte of in this case JavaScript. And finally, you need to know the carbon intensity or carbon factor, which is how many grams of carbon dioxide are released to the environment to produce 1 kilowatt hour. And then finally, the last number is roughly how many kilograms of CO2 stored by a tree in a year. Once you have these numbers, the formula is very simple. Just multiply the first three numbers. That will give you the value in grams. So you divide that by 1,000 to get the value in kilograms. And then you divide by 25 if you want to get the number of trees. There are a lot of really good resources with more information about this. I will share out the slides. Yeah, Twitter or Blue Sky. And yeah, and if you're interested to learn more about this, find me there. Happy to go. Thank you.
And while we're setting up for Henri, I have questions for you. Oh, also, just remember, if you have questions for Maxie, we'll be able to hang out a little bit after our talk.
Yeah.
And you know, we should have a little bit of time at the end.
I'll be here.
We're getting to the meeting again. Okay, so, all right. How many of you are from out of state? How many of you are from out of the country? This is a contest, by the way. All right, let's see. How many of you traveled across the ocean to get here? Hey, we have two. Two in total. Can't really fund this, I'm sorry. As a staff member, ineligible. Okay, so for our two that traveled across the ocean, tell us where you came from.
I traveled across the country.
Oh, okay, sorry. Okay. Oh, okay. So I'm trying to figure out who came furthest.
Germany.
Germany. Anyone further away than Germany?
I don't know, but I'm from you.
Oh, we might have to do some counting. There might be some math involved. And I don't know if I can do that at this hour after a couple of beers. But let's do it this way. Both of you, come find me tomorrow during the first coffee break, and you can pick out the book of your choice from the books that I brought. And right after check-in, so you can kind of like shop a little bit and decide which one. I'm sorry, what? Oh, yeah, that's what it is. We have books at the membership center. Yeah, excuse me. And you can also find out about membership there, obviously, and a lot of the other things that Smashing does. How many of you read the articles pretty regularly? Yeah, this is good. This is good. How many of you listen to the podcast? I really just recently started getting back into the podcast. They redesigned the podcast. So check that out too. Are we ready? Kind of. Oh, okay. Something like that. Let's see.
You know any jokes?
Nice.
This is hilarious because it's an ongoing Smashing staff duty for us to find dad jokes to share with the lady. So you are welcome to send those to to us or to Diddley. But yeah, unfortunately, a bunch of the ones I found were inappropriate. Were deemed unworthy of including in the program. So
There are no kids here tonight.
Yes.
Maybe I'll pull one for later from my list. I'll go find one that I feel comfortable saying out loud to the screen. But that's not appropriate for the meeting stage. Okay, do we feel ready?
Yes.
Yes. I have known Henri for quite some time. I think 2014. Something like that. Henri, I used to put on a conference called CSS DevCon. And one of the earlier ones in New Orleans. Yeah, and we would have a parade, and so it's a bunch of nerds on parade. It was great. So, without further ado, Henri.
see. Um, Hi, everyone. Oh, it's amazing. So the first time smashing conference, is that it? And gems. Yeah, exactly. Smashers and whatnot. So I'll get into the nitty gritty in a hot second. I'm just gonna say hello, and I spell like that because I'm Canadian and I'm French. And let's go. And I'm glad to be here in San Francisco. I haven't been here in a while, but at work, we call San Francisco EC2 US 1, so that's how I know it. You know, I was like, San Francisco? Oh, yeah, I know that. Anyhow, I tend to talk about, web performance. So it was really interesting to hear a little bit of it ahead of time. And we're going to hear some more a little later, I believe. But, we talked about core vitals, which we're going to hear about for sure a little later. And there's some announcements last week and whatnot, so all good. And that means we talk about metrics, paint metrics, speed metrics, timing metrics, we do all that. But I'm here to talk a little bit about metric tons. And specifically, you might think like, what is that all about? Because I did say I was Canadian. But I'm going to speak on a little bit of environment, which is really ironic because there was a little bit of that in the previous talk. We'll have to talk about that later. I ask people, what do you think of when you hear like environmental issues and whatnot? And I tell people, I just think of this car right now because my brother has a Tesla 3 all souped up. And so I sent him pictures of this Ioniq 6 that I think is pretty cool, and I'm not going to get it. But I still like it because it is an NEV. But we're going to talk a little bit about sustainability. And I say a little bit because it's really going to be like a surface conversation. It's really just about sort of like understanding what's going on in more recent times, and specifically digital sustainability. So I sort of kind of titled this Emission for Better Emissions. And again, emissions when it comes to digital sustainability is extremely complicated. We'll get into that in a hot second, but I will introduce myself. My name is Avi. You can find me on most socials under Avi Alberta, so Twitter, LinkedIn, Blue Sky, we mentioned, Mastodon. You'll actually find me there too. I work at an amazing company called Catchpoint, and I work on this great tool called Web Page Test, and we can find us both, find them all at these Twitter handles, by the way. Like I said, I'm from the greatest city on the planet, which is Toronto, Canada, not Toronto, Kansas. And I'm a bit of a distance runner, so I often share my journeys on Twitter with #DesWhoRun. So if that's you, by all means, go nuts. And we're going to talk a little bit about sustainability. And I said digital sustainability is super duper complicated. We'll even call it an inexact science. A lot of moving parts. And so many moving parts that you'll probably, if you start to dig around, you'll see people arguing about what it is that we're supposed to pay attention to. And, but there is a little bit of a baseline, which I'll talk about in a second. So it's really about like, how is the electricity that we're using, how is it generated, right? When you sort of get down to some of the nitty gritty, and again, I say some because there are a lot of moving parts and it's a little complicated. But we talk about things like information and communication technologies, ICT. Our reliance on like everything digital and then some. And in fact, ICT is sort of eating up 7% of the electricity across the globe right now, if you sort of add it all up. And again, I'm going to say, do not come back and tell me that it's 7.1 or 6.9. I'm telling you it's complicated. All right. So someone tomorrow is going to say, oh, that was wrong. ICT is also responsible for more or less, más o menos, right? 4% of CO2 emissions across the globe. And in fact, that's more, and that's another stat that you'll hear talked about a lot. It's actually more than the aviation industry for those of you who flew here. More than some actual nations, you know? So these are sort of like stats to start to paint the picture of the challenge that we are kind of faced with. And of course, when we talk ICTs, we've got to talk about data centers. We've got to talk about the networks. We've got to talk about the consumer devices that we all use, you know, the laptops that are apparently streaming right now. Should I smile?
Yes, but
Okay.
recording.
All right. Does my lawyer know this? So, and you know, location. We talked about location, how important that is. Let's talk about the carbon intensity that was talked about, I don't know, 5 minutes ago. You know, carbon intensity in Canada is not carbon intensity in China for the same services. All right, so these are things that we talk about. Let's look at the G7s in terms of carbon intensity. All right, top spot is not the greatest. Near the bottom kind of is. Hello, Canada. Est-ce qu'il y a des Français ici? Ouais, un petit peu. Ouais, pas trop mal, ok, d'accord. Because you know there are multiple ways to produce electricity. I'm going to do my Obama right now. Wind, solar, and everything else. The electricity that powers the data centers that we need. The data centers that send the resources down the wire that we use each and every day. When you use Google Maps to get here, because that was not easy. So more or less, these things start to add up and they become a bit of a carbon footprint, as we like to use a term. So, like I said, digital sustainability is super complicated. There's so much more involved. However, when the dust starts to settle and people are done arguing, they start to more or less converge around a particular data point that we know very well in the web performance space, which is page weight. And again, it's not only page weight, but page weight does have some factors into the carbon footprint. And again, you're gonna go home and read, man, he just lied to us for 10 minutes. But again, you'll see some discussions around this. And it's, like I said, it's a classic web performance metric. So, you know, it's comprised of a bunch of data, and I'm gonna run through some and just a few. Again, a classic page weight data, like at P75, we're probably looking at around a 4 meg site, all right? At P75, we're also likely sending down about 2.5 megs of images. I know this stuff by heart. At P75, we're doing about 857 kilobytes of JavaScript. And I mentioned those two resources because they're the top two outside of video. All right, so images, is that me? Images and JavaScript, very weighty. JavaScript also shockingly weighty considering its text, right? Now, at P75, what ends up happening, we are looking at about 1.38 grams of CO2 per site at the mean, okay? And, you know, another quick stat that we like to sort of parade around performance people, you know, the quickest request is the one never made. All right, we try to remind people if you don't have to load it up, don't. So the greenest request is also the one never made. All right, if you don't need to get another sort of like library in there, you know, you don't need to load to use lazy sizes. Is that what it's called? Because lazy loading is pretty much into the browser right now. So again, we've gone through some classic page weight data, but like I said, it's super duper complicated. You know, there are things that are being sort of like worked on right now that we're hoping is going to be create or provide more accurate measures. All right, so they're trying to get it done down at the browser level. all right, in terms of like CO2 emissions, everything associated. That was, I think, filed in April this year. Edge is also trying to do their work, and they realize it's complicated, but they want to see if they can surface this inside of DevTools, which would be kind of cool. And again, there's a working group taking a look at things, because this is the, well, I'll get into that in a hot minute. We're going to see there's like emerging standards coming around. So why are we doing all of this? Well, because you have situations like this. Million apologies. The greeting of the Gov. This is Gov UK. Anyone from the UK here? All right. Oh, thank you, God. They are creating mandates. I like this quote right here. Business as usual is no longer an option. It is therefore vital that Her Majesty's government, digital services, and ICT are responsible and resilient. They are making sure that moving forward, they want to be as green as possible. And that includes the digital services, and that includes procurement. So agencies that they're partnering with, if you're not showing or displaying or disclosing some initiatives around sustainability, they're not working with you. Europeans in the building? What? Okay, I was going to say, come on now. The Corporate Sustainability Reporting Directive. Starting 2024, companies that are 500 employees or larger are going to have to report their sustainability initiatives. And you know, Europeans do not play. Meta, 1.3, was it $1.3 billion fine today? Something like that. They are not playing around. So I mentioned that I'm at Catchbone. We have this incredible tool called Web Page Test. We're playing around with the idea of carbon reporting. We just added a feature recently. Again, there's some details involved, but for those familiar with Web Page Test, once you do a simple audit, you'll see at the bottom right, we're going to show you your estimate, quote me on that, estimate footprint. And it's going to look like this once you start to get into the details. But what we're going to do is we're going to let you know, like, is your domain using renewable energy? Yes. What about your third parties? Some. And then we're going to give you a little estimate of carbon footprint there as well. You can go check it out, try it out. We'd love to get some feedback, you know, because this is still early days. We call this a bit of a canary experiment. Because ultimately, performance, we're going to see a relationship here. Performance and sustainability are going to go hand in hand. Of course, there's a QR code if you guys want to try it out again. There's no prize if you do, but I'd love some feedback. I'll be around for the whole conference. And I just want to thank everyone. Cheers.
Okay. I looked at the dead. So we'll kill a little bit of time here. We're transitioning. Yes, I noticed the environmental need right away too. Okay. I just invited Death to a pillow fight. He gave me the opportunity to concede, otherwise I'd face the repercussions. Maybe, I don't know if anybody can make that rim shot noise, but you're welcome to do that. Okay. Like it. Yes, we have Michelle who is up next. Sorry, maybe I should have said that a little earlier. Here she comes. Okay. A guy walks into a bar and people start lining up to punch him. Yeah, right. That's the punchline. I like that one too. Okay. Okay. My wife says I'm the cheapest SOB on the planet. I'm not buying it. I need to hire a rich person. Oh, okay. My dad left his job. He wanted to pursue archaeology. His career is now in ruins. Yeah, okay, maybe these got rejected on other grounds, other than inappropriate. I'm willing to concede that. Okay, are we ready for Michelle? All right, please welcome Michelle Wu. No.
Hi everyone. It's been a hot minute since I've done a talk, but this one I was talking to Tammy about one of the last talks I did. It was in 2018 at Performance Not Now, and at the end of the Q&A, Steve Souders asked what my team would work on next. Oh, by the way, I work on performance at Citrus, and I said we're going to tackle our bundle sizes. There's a theme here of bundle sizes, and it's been a while since then. So this is part of the story of what we did. But first, why work on bundle sizes? You might have seen this graphic before from Annie Smani, but it talks about how performance is a journey. The user loads the page, they ask themselves, is anything happening? First page answers that. Then is it useful? When content is painted, then they can look at it and say, oh, this is useful or not. And then when JavaScript loads, then they can actually interact with the page in a meaningful way. So then it is usable. At Pinterest, we have a lot of JavaScript because we're a single page application. But we also server-side render our first page. So when you enter Pinterest.com, you might actually see the page become visually complete, which means you have buttons, you have info fields, and you think you can click on them, but actually the JavaScript might not be loaded and it doesn't do anything. And that can be a really sad, frustrating experience. So, as mentioned in previous talks, there is a cost to JavaScript, and JavaScript bundle size regressions can have a very large impact on client-side performance because not only do you have to download that JavaScript, but you have to compile it and execute it. That's a lot of time on the main thread. So what's the impact? Based on historical data of Pinterest, we found that over 25% of our regressions on the web were due to increases in the amount of JavaScript that we're loading. So if we could catch and prevent those types of regressions earlier, we would improve our user experience and also save a lot of time from our team having to investigate all those regressions. But first, what did we do in the past to try to address this issue? Well, we had big optimization efforts. There's several of these. This one was just one we did at the beginning of 2019. We basically just tried to reduce our entry chunk bundle, which is our main page bundle. And we did this by writing some code that's actually for this other site we support called Sterling. Then we had a regression, the increase that you see number 2 there from including the library for HLS videos. Then we found some other code for our home feed that we could split out. And then we actually split out Moment.js and HLS. And then we found some more Sterling code that we mixed. So that was a pretty successful effort. We reduced this bundle by 50%, which is pretty massive. And we had a lot of one-off initiatives that did something similar to this. We also stood up some monitoring and alerting. So these are some real-time graphs. We had these for all of our critical bundle sizes. Basically, we just, if there was a regression, an increase in the amount of JavaScript reloading, our team would get alerted and we'd investigate it. Here's an example of something we caught through this system. There was a 280 kilobyte increase. This was in uncompressed sizes, but minified. And that actually increased our home feed pinner wait time. There's a lot of letters there, that's what that stands for, by 700 milliseconds at P90. So pretty massive user impact. Luckily, we had the system up, so we could easily find the commit that caused that regression, and we just async loaded what was being imported, and that totally fixed everything. So kind of a manual process. We have to set up all these graphs. We have to maintain the alert thresholds. Then we would respond to the alerts by trying to figure out which commit introduced the regression, contact the PR author, discuss the problem with them, how to fix it, then wait for the fix to be deployed, then verify the regression is addressed. Not bad, but a little bit disruptive for our team, a little bit hand-holdy. So what could we do better? I think the PowerPoint version of this requires a lot of clicks for some reason. But we wanted to scratch out a lot of that stuff and just have alerts detecting bundle size regressions per PR. So what were the goals of this particular project? We wanted web engineers to understand the impact on bundle sizes from their code changes, and also to prevent bundle size regressions from entering fraud. So we want to make sure to communicate all bundle size impacts. So for every single route, every single bundle, we would actually report what the change in size was for every PR update, if there was a significant change in size. And also, we wanted to block critical bundle size regressions from being landed into fraud. So this is the result of that. We're on GitHub now, actually, but back then we were in Fabricator. So this is an example of what someone would see on their diff. It breaks down the bundle size changes by route, and then it just shows the delta for every single bundle. If there was a lot of routes affected, we would just do this summarized version of the total bundle size change was per route. And then if there was a critical regression, something that was affecting a route that was super important on the site, we would also send Slack alerts to them and to us and to whoever owned that route. I mean, whatever team owned that route. And then we had a full report in our CI system. What did we have devs do if there was a bundle size regression on their PR? So there's really only two steps. One, identify the root cause. And this was actually usually pretty easy because people were good about having their diff be small. So there's only like one or two imports, new imports in a diff normally. And you can either like comment one out and be like, oh, that one caused it, or just look at it and be like, oh, we're pulling in this big module. If it was really complicated, then we ran the Webpack bundle analyzer, which we saw in the first talk. And this helps to show all the modules in a bundle, so they can see what bundle regressed, run the bundle analyzer report, and see what modules are in that bundle, and compare that with the base of their branch. Step 2, reduce or eliminate regression. And again, this is pretty easy. Sometimes they just needed one export out of that module that they're importing, so they could just split that out into another file. A lot of times we recommended them to async load the new import, and if that was needed on the server, on the first render of the server render page, they could use loadable to do that. That just ensured that that code was loaded before hydration. If not, then they could use React Easy. So very simple changes to fix it. So here's an example. This is actually before we turn on blocking reviews on regressions. So someone imported this module that had a massive dependency tree, so it actually caused a very big bundle size regression and very big performance regressions. On our 490 page on MWeb, it was a 400 millisecond regression at P90 in the US, and then on our pin landing page, which we get like 10 million requests per day for, it was like 820 millisecond P90 regression. So very user impacting. With the bundle size check, we could see which PR caused this increase. It was a 41% increase to our client mobile route. And it was simple change. I just split that export out into its own file. That fixed everything. Here's another example. This was after we had blocking reviews added. So someone was actually adding HLS.js backend, and you might remember that we actually took that out. But it got back in. We wanted videos to be on MWeb, so that was added. That increased the client mobile bundle by 18%. So here, the PR author was a little confused what happened, so we kind of walked through this process step by step. But we saw in the bundle size report that there's a new bundle being added called One. That's just what Webpack named it. And we ran the bundle analyzer report, looked inside One, and it only had one thing in it, which was HLS. One thing for One. And we just use loadable to async load that, and that solved everything. So very, very simple. How this works, we basically read the Webpack stats file and generate an ASCII file every time someone lands a commit on master. We upload that file to S3. Then every time someone puts up a commit on, they put up a PR, we pull in the ASCII file for the base of the branch. Then we compare that against the ASCII files for the branch and see if there's any regressions, any bundle size regressions. This is just a health metrics dashboard that we have to make sure that the tool is running correctly. And here's just like a typical week where we see all the orange bars are alerts that went off, and then green is how many times the check ran. And results 2021, we launched this in March of 2021. It caught 21 critical bundle size regressions. That amounts to 3.4 megabytes of bundle size increases, and that's an unprecedented. We had 0 production regressions due to bundle size increases, so we cut out that 25% of our web performance regressions. We had a 0% false positive rate on the check, and it was self-serving. We barely had to do anything. PR authors knew how to root cause the issue and how to fix it, and we only intervened like maybe once or twice. Similar story in 2022, 35 critical bundle size regressions caught, over 5 megabytes of increases prevented, and that's after we switched to reporting in compressed sizes. So one of the reasons for this is that we actually scaled the checkout. A lot of teams wanted protection on their routes, so we started calling more routes critical, which is nice. And that amounted to 107 seconds of additional request duration that was prevented if someone were on a slow 3G network. And again, self-serving, we barely had to do anything. I mean, we were doing other stuff, but just not this. And that's it.
Okay, we are halfway through with our talk. Stephen Coleman is up next. In the meantime, while they're getting set up, okay, all of us have other talents. My other thing that I do is that I am a yoga teacher. So please stand up. Please stand up. We are halfway through the talks, and so I figured everybody's been sitting down for a little while, and you get up and get a little circulation going. Okay, so if you can, stand evenly through both feet. There you go, shoulders roll back. Now, I can't do it along with you because I'm holding a mic, but reach your hands behind and clasp your hands behind your back. Choose a spot on the wall, not a person, for balance. Okay, roll your shoulders back and lift your chest up. And breathe deeply. Now, here's the fun part. Keep watching your spot, and if you feel up to it, lift up onto your toes. And down. One more time. And down. One more time. And hold. Should we make this a contest? Does anybody else want a book? Can you stand like this? I could go for a while. Are we ready? Or are we still going? Okay, you know, we're gonna stand here for a minute. All right. Last one standing. I don't know, we could probably be here for a while, because this is kind of a fit group of people. Oh, yeah, okay, yeah. Let's see how long we can drag this out, right? All right. 3, 2, 1, come down to your heels. All right, let's welcome Stephen.
All right, everyone's brain clear, ready for the topic? Yeah, so I'm not going to be talking about performance optimization, but what I'm talking about might indirectly help save the environment. So giving you more time to worry about performance optimization. I'm going to talk about a subject that's close to my heart, which is the design handoff, and a project I've been working on to try to help fix the design handoff. A little bit about me. I've worn a lot of hats, like I'm sure many people in this room have. I'm mainly developer, background in computer science, but I've also worked a lot as a designer. I've actually been on projects where I'm just doing UI UX design. I'm not touching code, or even seeing the code. I've also lived most of my career as a software engineer. I've done a bit of business stuff as well for some of my projects. And I find myself, in recent years, basically alternating between the sort of designer world, wearing the designer hat, and the developer hat. And I noticed, first of all, like React and Figma, when you go back and forth between them, they're kind of the same thing. You're messing with layout, styling, design systems in both tools. It's actually kind of similar interfaces that are on top of different object models. But there's a lot of pain that you experience really on one side of the fence. But on the Figma side, like as a designer, it's really tedious to set up a Figma file to communicate to the developer what you mean and what you think is going to happen in the Figma object model. And then when it gets built, it's not what you expected it to be because the constraints are different. And you end up accumulating this design debt. Things aren't right. You have these back and forth. The PM will let you fix it. You guys have to ship, and things just kind of roll forward, right? And that's really frustrating as a designer when you're trying to get everything perfect. Designers are a little bit, obsessed with details, right? As a developer on the engineering side, it's also frustrating. You're getting wrong and inconsistent Figma, meaning it's like not using the right components in the design system. But it's not even showing what the site looks like right now. So designers is an alternate universe. And then these like mini waterfalls in your agile process where you're waiting for design handoffs, you're waiting for design feedback. Everything gets slowed down. There's a creepy feeling that you're being programmed by a designer who doesn't even know the code you're looking at. I mean, I'm not the first person to talk about the pains of design handoff. We all know these. We all know this has been going on for a really long time. And we all know that a lot of people have been trying to do things about it. What most people do is like, oh, let's make a handoff better. Design to code. Let's make tools that go from design to code. And we all, there's sort of inspection. You go into a Figma file. You can like look at the CSS. It makes it easier for you. There's like this Envision Zeppelin era we went through. There's a lot of tools. Classic and Animal are just two of the many, many tools that do, like Figma to React code. What I've found is that these kinds of tools to generate code work well for like simple marketing sites. They don't scale to things with teams where you have like a bunch of engineers working. You have to go like to live on and on and on and on. It's not just like a 4-week marketing project. They don't fit the life cycle, the complexity of actual applications. And people are really trying to push the envelope in this area, and it keeps hitting this wall. And so my thought from an engineer, like living most of my time as an engineer, I don't actually want the design world to come to my engineering world. There are more of us than there are of them anyway, usually. So what about flipping the script and going the other way? Instead of design to code, what if we went code to design? And code to design is actually something we all know. We know about Storybook. Most people are familiar with. What if instead of sort of handing off design to the engineering team, we handed off our code to the design team to work with? And what we see in the few things that have been done in this area is that there's not a lot of, it's not really deep. Like Storybook allows you to inspect the results of the code. And a lot of people end up using dev tools, which shows you the DOM, which is sometimes related to the code, sometimes the CSS is one-to-one. But what about what designers do? Not just like looking at what we've coded up, but actually tweaking and creating and working with the code in a meaningful way. And so I started working on this project to try to enable that, to enable designers to work on top of our code in a way that made sense to them. I built this thing. I called it Component Studio as a code name. It was kind of like a storybook with editing. So the idea is you could load up components and you could click around a bit and you could edit their properties. I built this. Well, I thought it was pretty cool until I started looking around at code bases. I started pulling down different sorts of projects, trying to set it up. They basically worked on basic components. And I noticed this thing about code bases. This is your typical production code base. And these are what I call isolatable components, right? There's nice atoms in your design system and presentational components, right? That's actually like a small and pretty boring and pretty tame piece of your code base. What actually, the interesting stuff, are there's like big components and a redocument database, all this like stateful stuff happening, and all this code. And these are the ones you can't just like generate into your code base. That's where things are interesting. And so, and that's where all the design challenges designers were working as a designer, the things were wrong. It wasn't like, oh, you got the primary button wrong. It was like on this form where all these things in this one state, where you have like 4 things, the layout doesn't work because of blah, blah, blah. And so the component studio approach wasn't sufficient for it. So I started building this thing that I call Web App Studio. And actually got some friends and one stranger together to work on another project that we're calling Mighty Mill. And what this is basically a tool that allows you, it's like a designer-friendly interface to basically build on top of a running website. So here, basically you see on the left, this is actually the JSX hierarchy. This is a Netflix clone project I found on GitHub that I loaded up. And the idea is as you click around on the left, you see properties on the right, so that's the style components. And you can basically go in, change design tokens. I'm going to go really fast in this video, it's only a 10-minute talk, but basically give contributions by sort of messing with your project. And here you can see stuff through. Here's another example of like building out that component. So using this like digital drag and drop. Basically the idea is you're dragging and dropping JSX instead of Figma stuff. So it feels like Figma is actually doing JSX and writing JSX code instead. So here's an example of like making a component, and you can build components, you can add it to your code base, and you can drop it in. And then here you can see the kind of gifts we get out of the system. So 2 seconds, there we go. Yeah, and so instead of code generation, because you're doing these little moves, and I'll explain in a second, you get a really sort of detailed gifts that are kind of like what you do if you're a hand programming it. The basic idea of how I built the system, or actually it wasn't me, how we built the system, was on the left is sort of your standard workflow when you're developing a front end. You do some code, you're running a web server, you see it in the browser, you get the code until you get the design looking right. So that's a sort of standard thing on the left. And the way this tool works is like you basically have an iframe that shows in the design tool, iframe shows that running version of your website, like full site, everything. And then you do design moves. I mean, every little design move you do with some technology does code updates. And I'm happy to talk more about the technology. 10 minutes is not very long. It's really cool, but not box. Anyway, and so basically, you do every design move does a code update. And so you end up going through this circle where you do a code update, hot reload refreshes it, it shows again the design tool, you can do another design move, and basically through this loop, you're evolving the code base forward by doing visual design stuff. And because it's all in the language of code, if like there's some branch here where like, oh, another, you merge a different branch, I guess a fork. Anyway, good terminology overlaps in English. But anyway, if you're doing other development, you go to development and bring it back and keep going. I'm learning some interesting things through working on this project. One thing, like there have been some surprises, and this is really the surprises. First is actually, we're finding it faster when we're developing to do style tweaking this way. There are a number of people who've done these like parallel visual code editors that just are faster than typing. But this one, because of the drag and drop, because it's kind of like the difference between Finder and doing things in terminal, just how your brain works. You can do the visual stuff in the visual way. But what's really surprising, another thing is the mind work for designers. And you think, oh, you expose a little bit to the code to designers, they kind of understand. Like, I didn't realize how far away designers were from actually understanding what was going on in the project. Like, working with a designer on a Chakra project, he had like the wrong breakpoints. He had a Figma file with like all the Chakra stuff in there. He had his breakpoints wrong, so he didn't even understand what the breakpoints were. He was doing this design with like a small and wide version of the screen. He gets in there and starts playing with Lightmel, and he realizes there's a lot more than just 2 breakpoints. Like 5 things transition, and started to change his whole way of thinking about the design. I think the most interesting thing for me, in terms of my own thinking about the handoff, I, like many people who've gone on this path, have been like, let's eliminate the handoff. Let's eliminate the handoff. Like, we just shouldn't have it, it's bad, right? But what I learned is, it's immature to think you can eliminate handoff. There are handoffs all around. Like, when we engineer together, we're handing off our code through PRs, and it's normal. Designers are handing things back and forth. The thing that smooths over the handoff is actually not, is this idea of overlap. That their task is like, the developer could do it, or a designer could do it. And that idea that the responsibility could be done by one person or another. And it's all sort of living in GitHub. But if you want to reorder the page, or you want to make the header bigger, or make the button more prominent, the designer or the developer can do that. And so you get this real shared language, and that's what I think is going to heal the relationship between design and development. Anyway, thanks everyone for listening. As you can tell, I'm super passionate about this and happy to talk to you about it. And we have sort of an alpha phase project right now. There's going to be one of the first people to give it a try. Certainly open to, and just have theoretical discussions about the end offer are good too. So anyway, thanks everyone.
Okay, we have a small schedule change. Up next is Tammy Everts. But I was reminded of something that I want to bring up. Our volunteers are amazing, and I would like all of our volunteers to stand up. Please, 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 I'm making them stand. But could everyone please give them a round of applause. We could not make this And part of the reason I was reminded is that one of the volunteers sent me a joke to share with you. Okay, so here it is. Not to brag, but I made 6 figures last year. I was also named the worst employee at the toy factory. I think that's better than the ones I did. Okay, I'm going to hand things over to Tammy. Thank you all so much.
I have to think about that. Why don't it's first like a dad joke or a dad joke you actually have to like process? So hi, I'm Tammy Everts. I spoke earlier at the beginning of this evening. I work for a company called Speaker, and I talk to a lot of people who use Speaker tools, who care about performance monitoring, and so a big part of my job is just helping people to use our tools, but also just to kind of interpret or kind of act as an interpretive layer between all the work that is constantly happening behind the scenes in the tools and the browser and the browser vendors about which are the metrics that we're tracking right now, why you need to care about them. So I feel like my job is I'm constantly learning and then trying to pass that information along to other people. So what I'm here to talk about today is, let's go back here, IMP. How many people are familiar with Core Web Vitals? Okay, so about a third. How many people have heard about interaction to next paint? Okay, so good. Everybody put up their hand and go, okay, well, let's go home. Okay, so we're going to talk about that today, and I'm going to give you like the quickest explainer I think I could possibly give. So a little bit about me. As I said, you can find me here. This is my face. I use the same picture everywhere, so if you're looking for me online, this is the picture to look for. And you can find me on Twitter and Mastodon. Webperf.social is a really good community if you're looking for a server for Mastodon and you're really into performance. Let's get started. If you're looking at this and it's kind of making you cringe, then you've probably been doing performance things for a long time. These are just a few of the many, many, many acronyms. I was at a conference last fall at perf.now that Michelle mentioned, and somebody used the phrase 3-letter acronyms, TLAs, because in the performance community, we really like our TLAs. And so these are just a handful of the many, many TLAs that I've encountered over the years that I've been doing performance things. And just to give you a little more background, I've been in the performance community for about 15 years. And before that, I did usability things and usability testing and kind of user labs for about 5 or so years before that. So I've been doing this for a long time. I've seen a lot of metrics come, I've seen a lot of metrics go. In SpeedCurve, we track dozens and dozens and dozens of metrics. We have over 50 synthetic metrics. At last count, over 30 different real user monitoring metrics. Tons and tons of third-party metrics. Like each third party generates its own kind of like little mini waterfall and a set of charts that we are for metrics that we track for those, and countless custom metrics. So there are a lot out there. And a lot of us were really relieved in 2020 when Google announced Core Web Vitals. So basically what Core Web Vitals do and what Google's intention was to do was to take this plethora of metrics that we all have that frankly is confusing. You know, all those acronyms, even for somebody who works in this space, like it's my full-time job to do performance things. And I sit in meetings with people whose full-time job is to do performance things. And we'll sometimes be like, how's that one calculated again? Like they get really, really, really esoteric. And so what Google did was an attempt to really define 3 core metrics that would be vital and that people should focus on. And the goal was to have them be very, very user-oriented. So there's a lot of different metrics you can track that are kind of tracking things behind the scenes that are also important. But the goal of Core Web Vitals is to measure performance from a user-perceived perspective. And so in the beginning, Google said, yeah, let's do Core Web Vitals. And these are them. There is largest contentful paint. I don't know how well anybody can read this at the back. Largest contentful paint is measuring is something actually rendering in the browser. First input delay, which is the page responsive, and then are we just gonna end up in Oz tonight? I'm a little. And then cumulative layout shift, which measures sort of how janky the page is. And so those are kind of the 3 original metrics. And so at Speaker, we've been measuring them for quite a while. This is as kind of a screenshot from the vitals dashboard where people can see their different vitals, and if they want to, they can expand each of them and learn more about kind of what to fix on with regard to each metric. But there's a problematic one, which is first input delay, that one in the middle. And I don't want to go into a lot of detail about all the various problems. Basically, it was a really good first attempt to measure interactivity. And so what first input delay does is it measures the amount of time it takes for the browser to respond to any kind of user action. So it's like a click, a key command, attach a key, I'm losing my words, touching your screen. And you can only measure it via real user monitoring tools. So as I said, it's a very noble effort to kind of try to measure interactivity. As it turned out, there were a lot of flaws, there were a lot of notches, and at Speaker, because we can measure first input delay and then create something called correlation charts, we can actually do something, and I'm going to show you those in a second. We can do something where you can actually see what is the correlation between whatever metric you're tracking and actual user behavior. And before I go any further, I want to owe a little debt of gratitude to Cliff, who I work with. He's not here, but Cliff has been doing performance things even longer than I have. And one of the things that he's really, really, really good at is not just understanding the metrics, but really doing deep dive analyses of what the metrics are measuring on using real data and figuring out, are there actually any correlations between the metric and user behavior. And so every time a new metric emerges on the scene, Cliff is kind of there. He's like a pit bull, but like a really friendly pit bull, and he just like kind of gets it by the pant leg and he just shakes it until it shows us if it actually means anything. And so he did this in the early days of FID, and this is a correlation chart. And so I don't know how well anyone can make this out. It is a distribution histogram that shows the distribution of FID across a lot of sessions. And we also tracked conversion rate. So again, because we're using real user data, we can do this. And what usually a correlation chart, if it's a good correlation chart, or to be specific, if you're tracking a really meaningful user experience metric, what we typically find in a correlation chart is that for the faster cohorts of pages, conversions are higher, and then conversions start to drop as the cohorts get slower. Or if you're looking at something like bounce rate, for the faster cohorts, bounce rate is higher and gets lower as well. So, lower gets higher. And so you can read about his analysis. It's all in a post that he wrote a couple of years ago. But what we really found was that it just wasn't really correlating to any kind of user behavior that we could track. And we looked at a lot of data. And so that was a bit of a red flag for us. We continue to track it, it continues to be available in the product, but we didn't really advise customers to lean on it too heavily as a metric. And we're not the only people to have kind of found a few caveats in FID. So this is kind of just our story. And so based on this, the Chrome team recently announced that they're going to be deprecating FID in early 2024, and they're going to be elevating a new metric called interaction index paint as the core responsiveness metric in Core Web Vitals. And you can read about that. I try to provide links in all of my slides. So what is interaction index paint? It, like FID, measures a page's responsiveness to user actions, so it's measurable and run. But unlike FID, it observes latency and reports on all user or almost all user interactions. So it's kind of aggregating the sum total of the latency in those interactions. And it's measured via the user event timing API. It's supported in most browsers, not Safari, Face. And as with all the Core Web Vitals, Google has recommended thresholds for how fast they want IMP to be on your pages. So these are Google thresholds. And you can see that I've indicated that these are at the 75th percentile. The reason why you want to track things at the 75th percentile is, I don't know about you, but I don't want only half of my users to have a satisfactory experience. Ideally, you want to know that people at 75th percentile are also having a good experience. Ideally, 95th or 100th, but 75th is a good place to start. So these are the recommended thresholds. So a good IMP time is under 200 milliseconds. And that's, as I said, that's the sum total of all interactions. I don't want to talk more about kind of how it's measured. You can go to the DevRel blog for Chrome and get more details. And so, of course, going back to Cliff just kind of dove into this metric. We were tracking it in Speaker for a while, kind of quietly behind the scenes before we added it to the tool for our customers to use. And what we found, well, we've already talked about how the metric is measured. As I said before, FID is for first interactions only. IMP is for all interactions and measuring overall responsiveness. And the goal here is that if we're measuring responsiveness overall, then ideally, how you engage with a page isn't necessarily going to be confined to just that one click that you have on the page, that one interaction you have on the page. You're going to have multiple interactions on the page. So measuring overall responsiveness should correlate to user behavior. And as I said, we've been tracking it in Speaker for a while. This is some historical time series charts. And we found a couple of things. We found that, not surprisingly, the numbers for IMP are slower than the numbers for FID. And actually, that was one of the red flags in the really early days of FID, was that, wow, like some of these numbers are really, really fast, and yet the page doesn't feel great. So what's going on there? So if you are already tracking FID and your numbers are really great, you might have a little bit of a wake-up call coming whenever you start to track IMP in your charts, but that's okay. Everybody's experiencing the same thing. Your site didn't get worse, your metrics got better. And how well does it correlate to user behavior? Well, we looked at a lot of data. You can see 4 different correlation charts here where we're tracking it against, what is this one? Oh, we just tracked against conversion, sorry. I thought it was mouse rate. I'm leaning heavily on Cliff's research here, so I'm just still learning about some of these charts. So what Cliff found pretty consistently is that across all the different sites that we looked at, when IMP got worse, conversions went down. There's a general trend in that direction, and it's more noticeable in some sites than for others, but this is definitely a noticeable trend. So how do you optimize IMP? Well, it's interesting. I wasn't actually paying attention to this whenever I was reading the outline of the different talks for tonight. But it's funny how many of the talks were about JavaScript, because it kind of seems to always come back to JavaScript these days. So a lot of the issues that are affecting IMP hard to do unoptimized JavaScript, too much JavaScript, etc. So I don't want to get into all that, but you can go to the Google Web Dev blog and get more background there. I really like this quote that from the post that he wrote about his analysis, because I think it kind of really sums up, even if you're not seeing necessarily a direct correlation in your charts, or you're not seeing a direct, I mean, one of the goals of the Core Web Vitals from an SEO perspective is if you improve your vitals, because they are a ranking signal in your search ranking, then your search ranking will improve. And that's nice, that's good. But I kind of lean more on, having quality content, and also just, should you care about user experience, even if it's not affecting your search ranking? Should you care about just providing a really fast, delightful, joyous, seamless online experience to your users? And so I really like this quote from Cliff. I'll read it in case anybody can't make it out. Doing the right thing for your users, including creating a responsive and delightfully fast experience, will have a lasting impact on your brand. And yes, your revenue. That's everything. Well, to start anyways, come find me if you want to talk more about IMP or any of the other Core Web Vitals. I'm here for the next couple of days. Thank you very much.
Okay, so our last talk today is by Rin Chin, who also just happens to be one of our volunteers. So you'll be able to talk to her at the conference as well, even if you don't get to talk to her tonight. You feeling ready? Yeah?
I'm gonna let you decide because it's 8 p.m. This is,
Yeah.
how's the energy? How's the vibe?
We're doing this. We're doing this. Are you ready?
This is not a tech talk. This is, it's gonna get emotional. So that's, are we still feeling?
Okay. So,
Whatever brings out the tears.
okay, I'm not gonna dad joke you now. I feel weird. Okay, well, all right. I have one little tiny one. Indulge. Okay. We all know where the Big Apple is, but does anyone know where the mini apple is? Yeah. Okay. Yeah. Are you sure? Thank you all. Welcome, Red.
Usually I just wing this, but I'm pretty sleepy, so I'm gonna use my notes. Okay. So good? Yeah. All right. So developing emotional resilience is the work of a lifetime. Usually I teach this as a workshop in small groups that takes at least an hour. We have like 9.5 minutes. So we're going to explore the concept, a couple of the most effective methods you can use to cultivate it in yourself, to use in your work and in your personal life. And then you can decide from there how deep you want to get into it or not. So I'm not yet an engineer, and I'm definitely not an artist. But what this talk lacks in technical expertise and visual appeal, it's going to make up in outdated pop culture references. Has anyone been to a nerd night before, incidentally? Yes. What city? Awesome. I started Nerd Night San Diego. For the rest of y'all, there's probably a Nerd Night near you. It's like TED Talks with beer and real science and memes. So it seems relevant to your interests, probably. I haven't met most of you yet, but I get the vibe. This is not going to be a Nerd Night talk. It's not going to. You should go though. All right, quick disclaimer. Like clarification. Emotional resilience is essential to mitigating burnout, but burnout cannot be prevented only by cultivating emotional resilience in yourself. The only evidence-backed burnout prevention has to come from the top down. So from HR management, companies like to send out a lot of scented candles and advice on, meditation. That's not what this talk is going to be about. That's a whole other thing. We're just going to focus on what we can control tonight. All right, let's dive in. So let's start by defining emotional resilience. Becoming emotionally resilient doesn't mean turning into a smile robot or white knuckling through the frustrations of a workday. It doesn't require immediate fixes that briefly soothe and distract you. These often end up being unhealthy habits. We all have our go-tos. Candy for me, vaping for some, Reddit for probably a lot of people here.
Yes.
Maybe we enjoy yoga or running, but those are really hard to do in the office. So a lot of times we end up turning to the unhealthy quick fix. Emotional resilience is getting to know ourselves and talking to ourselves like we were our best friends or our best work friends, separating our work product from who we are as people. And most of our lives, we've been doing exactly the opposite. So it takes practice. It's not something that we learn in school, even though we should. So we've got to develop emotional resilience by noticing the cycle. We think, we act, we feel, and it makes sense objectively on a slide with fun shapes and colors. But in real life outside of this talk, the cycle happens so quickly that it feels instantaneous, and we hardly notice there's a cycle at all. If our current routine is getting our work done while gradually eroding our mental and physical health, we need to experiment until we find a sustainable balance between productivity and health. And to do this, we need to get comfortable with the idea of being compassionate with ourselves and developing self-awareness, which is super uncomfortable for a lot of people. Not that kind of self-awareness stuff. All right, so we're going to start with the ABCs. So the antecedent could be an event like a conversation with a coworker or an email from your boss, or most often just a bunch of thoughts that have been swirling around your head. The behavior is how we respond, scrolling through our favorite app, shouting the negative self-talk, and the consequence is the aftermath. Maybe our physical health starts to deteriorate, or maybe our work relationships, or maybe our personal relationships do too. Maybe we think and talk about our work troubles, even when we're not there or at the weekends. But the cool thing is, we can significantly influence the ABCs just by noticing them. And maybe you can do it easily in your head, or maybe you can make like a handwritten 3-column sheet and write it down with different colored pens on your standing desk like a totally normal person. Either way, I recommend you try it, even if it's just for a day, during one of your work days, and write down the ABCs as they come up. And just the practice of writing it down and noticing it, I would be surprised if you didn't feel a difference at the end of even one work day. And what you'll probably notice is a clear pattern in the root cause of your stress. All of your stress. But just in case you don't rush back to your offices after the conference and start making ABC charts, the next slide is an answer to pretty much all of life's stresses, as far as I've been able to tell. And I'll give you a few seconds of quiet so you can read the next slide yourself to observe. Unless you can't see from the back, because I also didn't bring my glasses so I can read it to you. All right. So it all has to do with control and the need for control, and letting go of control if you can't see the back. You can't control what other people choose to think, feel, do, how they choose to do it. And when we try, we experience all of these negative feelings. That sums it up. And this is our solution. It's the most simple, and it's also part of a lifelong practice. In the moment, our feelings seem like they spring out suddenly out of nowhere, but that's because that ABC cycle happens so quickly. And it really is a choice, and we really can make our own decisions once we start practicing, slowing down enough to pay attention to that cycle in ourselves. It's especially important to not fall out of practice when things get tough. So with that goal in mind, the following are research-backed methods to help cultivate healthy stress management. There are a decent number of them, so there's got to be something for everybody in here, I think. All right, so sitting with yourself. The important thing to note about this is a lot of people don't like to feel feelings, and that's totally understandable. But even though it's uncomfortable, it's not unsafe. It's not going to hurt you, no matter how bad the feelings are. Self-care. Kind of a triggering word, because that goes along with the company branded scented candles. But it's got to be a non-negotiable in whatever form that takes for you. And reaching out to other humans and creating deeper connections. And I say humans because cats don't count. And also, introverts gotta do it too. And just try one human at a time and we'll be fine. Making time for gratitude, even if it's just thinking of one thing a day, science-backed. And not rushing to fix things. You can go for the quick, sugary, or vapey, or ready fix. But that's not gonna do you any good in the long term. So be thoughtful about your choices. Meditation, 10 minutes is a day. If you keep it up for a while, it's actually going to change your brain physiology, and it's truly amazing, and it's clickbait but true. All right, we have like 2 minutes left, so yeah, this is going to be about 6 breaths in 1 minute. It's going to feel like an eternity for half of you. But this is one of the single best habits that you can cultivate in your life, in work or outside of work. And you can find me later if you want the science behind what this type of breathing does for you. So if you're feeling up for it, we're going to do a minute of breathing. And if you're feeling up for it, here's how it's going to work. It's through your nose. You don't have to open your mouth. They are all weird. You're going to breathe shallowly, not deeply, but shallowly into your belly. So your belly's moving and your chest is not moving. And that's all. Through the nose, in and out through the nose, shallowly, so the belly's moving and the chest is moving. And if you want to give it a try, it kind of helps sometimes if you're just starting out. You can put one hand on your chest and one hand on your belly so that you can feel the top hand not moving and the bottom hand moving. Now I'm going to see if the sound works here, because the music goes up in pitch for breathing in and down in pitch for breathing out. And if it doesn't work, I'm just going to move my hands apart for breathing in, pull together for breathing out. So let's see. Okay. I'm going to set timer and we're going to get awkward. And I'm going to move my hands. All right. is a minute. You uncomfortable? No?
That's great.
Okay. So, thank you for showing up today with open minds. Thank you for listening to a very, very sleepy final speaker. Let's do our best to get to know ourselves. And if you want to catch me later tonight or later this week, happy to talk about physiology of brain chemistry. I was a scientist and not an engineer. We're getting there, it's going to happen, but happy to talk about breathing or ice cream or anything you guys like. So thank you so much.